Well, friends, come towards the next chemical reaction of the monohydrate alcohols, and it is the dehydrogenation of the alcohols. So, dehydrogenation of alcohols. Now, in this reaction, only the primary and secondary alcohols undergoes dehydrogenation, and to form aldehydes and the ketones are the products, whereas the tertiary alcohols undergoes dehydration. Now we will see here that one examples from all these primary, secondary and tertiary alcohols. For example, like the CH3CH2OH, it is the ethyl alcohol here. Now this the vapors of the ethyl alcohols are passed over heated copper at 573 Kelvin temperature, and here the dehydrogenation takes place here. De means the removal, and the hydrogen H2 gets removed here or eliminated here, and remaining is that the CH3 CHO, and it is nothing but the acetaldehyde here. Acetaldehyde plus H2 here. Means here primary alcohols are when passed over heated copper at 573 Kelvin temperature to form the acetaldehyde. Now we will take here that the second example from the secondary alcohol, and alcohol is the isopropyl alcohol here. Now the vapors of this isopropyl alcohol again pass over heated copper at 573 Kelvin temperature, and again here that the dehydrogenation takes place and to form CH3 C double bond to CH3, and it is nothing but the acetone here. Means in these reactions here aldehydes and the ketones are formed, and here these alcohols here undergoes dehydrogenation, whereas the tertiary alcohols do not undergo that the dehydrogenation, they undergoes the dehydration reaction here. Now this should be the here tertiary butyl alcohol here. Okay, and this tertiary butyl alcohol undergoes dehydration and to form the CH3 C double bond CH2 CH3, and from this CH3 one hydrogen atom and this OH to form the H2O molecule, and it is nothing but that is the isobutylene. So in previous period we have seen that as here in the tertiary alcohols there is a absence of the alpha hydrogen atom. Okay, therefore it undergoes the dehydration and to form the alkenes. Here the alpha hydrogen atom means here to the tertiary carbon atom, here directly the hydrogen atom is not attached here, just like in the here primary and the secondary alcohol. Therefore it undergoes the dehydration. Okay, so this will be the here dehydrogenation of the alcohols. Now one more reaction is remain here from the alcohols, and it is here a reaction with the phosphorus halides here. So our next reaction is the reaction with phosphorus halides, or reaction with phosphorus halides. Phosphorus halides. Now the phosphorus forms two types of the halides. Okay, and which are the two halides here? One is the PX3 and another is the PX5. So PX3 means the phosphorus trihalide and PX5 means phosphorus pentahalides here. Okay, now we will see here that the first of all reaction with the phosphorus trihalide. Reaction with phosphorus trihalides. Okay, and in this phosphorus trihalide there are the PCl3 means phosphorus trichloride, second is the PBr3 phosphorus tribromide, and third is the PI3 phosphorus triiodide. But for all these reactions here, that one common reaction is that ROH alcohol here. Now this alcohol reacts with the PX3 phosphorus triiodide here. Here in this reaction you have to take like the 3 times alcohol here ROH here to form 3 times RX alkyl halide. Alkyl halide. And in this reaction then which part is remain here? Now in place of this OH hydroxyl group X gets here like the present here. Actually it is the nucleophilic substitution reaction. Why? Because in this reaction OH is a nucleophile and this nucleophile gets substituted by the X nucleophile here. So in this reaction that the phosphorus and the 3 times OH groups are in here. POH 3 times and it is a phosphorus acid here. Phosphorus acid. Or this formula we can write in another way also. Means here hydrogen is present here for the 3 times, phosphorus is for 1 time and oxygen is for the 3 times. So H3PO3 is formed here. So this is the general reaction of all these reactions. Now in this reaction just you have to do change here that. Now here when we take here that the PCl3 here, PCl3 is phosphorus trichloride. Then what happens here? In place of X here, right? Cl is taken and it is the phosphorus trichloride. Now in place of again here that the X here the Cl is present here. Okay, so it is the alkyl chloride here and the byproduct is the same one. Here the reaction is like this here. Alcohol when reacts with the phosphorus trichloride to form that is the alkyl chloride. Okay. Now in place of this alkyl group, you have to take here methyl propyl and N-propyl as a primary alcohols, then isopropyl as a secondary alcohol, and the tertiary alcohols here. We first I will take here that some examples here. Now 3 times C2H5OH here. Now methyl alcohol when reacts with the phosphorus trichloride to form here 3 times C2H5Cl, ethyl chloride, and POH 3 times here. Reaction is like this here. Ethyl alcohol reacts with the phosphorus trichloride to form ethyl chloride here. Now in place of this ethyl, when we take here that the methyl CH3OH, ethyl alcohol, then methyl alcohol reacts with the phosphorus trichloride to form methyl chloride. Okay. Or third one, when we take here that the N-propyl as a alkyl group, then the alcohol is the N-propyl alcohol here. N-propyl alcohol, the reaction is like this here. 3 times CH2OH. It is the N-propyl alcohol. It reacts with the phosphorus trichloride to form 3 times CH2CH2Cl. It is the N-propyl chloride and the byproduct is the phosphorus acid here. Okay, so these are the examples of the primary alcohols. Now come toward that the secondary alcohol. Now in the secondary alcohol it should be the secondary propyl alcohol or the isopropyl alcohol. This isopropyl alcohol reacts with the phosphorus trichloride to form CH3CHClCH3. It is the isopropyl chloride or the phosphorus acid is formed. Okay, and come toward that one more reaction from this here that as a tertiary alcohol here. Now the tertiary butyl alcohol reacts with the phosphorus trichloride. Here in this reaction OH nucleophile gets substituted by the chlorine here and to form CH3 here Cl tertiary butyl chloride and the phosphorus acid. Okay, so in this way we have seen that the reactions with the PCl3. Now come toward that the reactions with the PBr3. Now just you have to do change. In place of the Cl you have to take here the Br. Okay, means here just I will tell you here orally. When alcohol reacts with the phosphorus tribromide, means PBr3 to form RBr, alkyl bromide here, and the byproduct is the same one here. But now in this reaction that here you have to write here on the arrow 2p oblique 3br. Now actually Why it is written here that 2p of PbR3? Because that in place in comparison with the PCl3, PbR3 is less stable. Therefore, PbR3 is prepared at the reaction time from the red phosphorus and the bromine here. Means actually the reaction is like this here. When the alcohol reacts with the phosphorus tribromide here, means red phosphorus and the bromine, and to form the alkyl bromide here. Alkyl bromide. Alkyl bromide. Okay. Now, in place of this, here that the PCl3, we have to take again that the PbR3. Means the reaction is like this here. When ethyl alcohol reacts with the red phosphorus and the bromine to form ethyl bromide. Okay. Then next reaction is that when N-propyl alcohol reacts with the red phosphorus and the bromine to form N-propyl bromide. And in the last reaction, in next reaction, when isopropyl alcohol reacts with the red phosphorus and the bromine to form the isopropyl bromide. And in the last reaction, that when tertiary butyl alcohol reacts with the red phosphorus and bromine to form tertiary butyl bromide. Okay. So in this way here that this finishes that the reactions with the PbR3, and third one, that is the reactions with the Pi3. Again here that the Pi3 means that is the phosphorus triiodide here, and this phosphorus triiodide is also less stable here. Like that here PbR3, Pi3 is also prepared at the reaction time, and from whom here? From the red phosphorus and the iodine here. Okay, so reaction is like this here. When alcohol reacts with the red phosphorus and the iodine to form alkyl iodide here. To form alkyl iodide, and the reaction is like this here. Now, come to the example here. When ethyl alcohol reacts with the red phosphorus and the iodine, means 2p and 3iodine, to form ethyl iodide here, C2H5R. Okay. Then when N-propyl alcohol reacts with the red phosphorus and the iodine to form N-propyl iodide here. Okay. Then in the next reaction, when isopropyl alcohol reacts with the red phosphorus and the iodine to form isopropyl iodide here. And in last reaction, when tertiary butyl alcohol reacts with the red phosphorus and iodine to form tertiary butyl iodide. Okay, so in this way here that this finishes the reactions with the phosphorus triiodide. Now come toward that the second one reaction, and it should be the here reaction with phosphorus pentahalide. Now in the phosphorus, just like that in PX3 there are the three halides we have seen. Which of the three halides? One is the PCl3, second is the PbR3, and the third is the Pi3. Like that here in this phosphorus pentahalide, here again there are the three halides here. One is the PCl5, it is called PCl5, it is called phosphorus pentahalide. Then next one is that the PbR5, it is the phosphorus pentabromide, and third is that the Pi5, it is the phosphorus pentaiodide here. But here just we will discuss here reaction with only here that the PCl5, means phosphorus pentachloride here, and not with the phosphorus pentabromide and phosphorus pentaiodide, because these phosphorus pentabromide and phosphorus pentaiodide does not exist here. Means here the reaction is with only PCl5, and the reaction is like this here: ROH alcohol plus PCl5 phosphorus pentachloride. Again this is a nucleophilic substitution reaction. Means here from this alcohol here OH group gets substituted by the chlorine atom to form RCl, alkyl chloride. Then the byproducts are here from this OH here, that the hydrogen atom and one chlorine to form that the HCl. Then the here again that the byproducts are the one is that is the phosphorus and that the here that phosphorus and the 3-chlorine, it is to form that the RCl alkyl chloride here, RCl alkyl chloride is formed here. Okay, then the next one that is the from this alcohol R add the Cl5, RCl alkyl chloride is formed. Okay, then in the remaining one that the here OH group is remain in the OH group here that OH group and that the 4 chlorine atoms are remain here. Now here the from this here that the byproduct here, which part is now here, byproduct is here, one is that is the phosphorus P, then O here oxygen atom, and here that the 3Cl3 POCl3 phosphoryl chloride here, and one hydrogen atom and one Cl here, that HCl is formed here. It is a phosphoryl chloride here. Now in this way here that the reaction is like this: when alcohol reacts with the phosphorus pentachloride to form the alkyl chloride here. And in this reaction the examples are the same one here, like here that when in place of R, when we take here that the methyl group, then methyl alcohol is formed. When methyl alcohol reacts with the phosphorus pentachloride to form methyl chloride here. So I will do here change the same reaction when CH3OH methyl alcohol reacts with the phosphorus pentachloride to form that is the CH3Cl methyl chloride here. Okay, and the byproducts are the POCl3 and the HCl. Now if we take here that the C2H5 methyl alcohol when reacts with the phosphorus pentachloride to form that is the ethyl chloride. Okay, when the N-propyl alcohol means CH3CH2 CH2OH N-propyl alcohol reacts with the phosphorus pentachloride to form CH3CH2 CH2Cl N-propyl chloride here. Okay, then when we take here that is CH3OH CH3 isopropyl alcohol reacts with the phosphorus pentachloride to form CH3 CH Cl CH3 isopropyl chloride, and the byproducts are the phosphoryl chloride and the HCl. Then the next reaction that when tertiary butyl alcohol is taken, then this tertiary butyl alcohol reacts with the phosphorus pentachloride to form tertiary butyl chloride, and byproducts are the POCl3 and the HCl. Okay, so this finishes that reaction with the PX5 here. Now only one reaction is left here, and this reaction is very important here, and the reaction is with SOCl2. This SOCl2 is known as the thionyl chloride or the sulfonyl chloride. The reaction is like this here: when ROH alcohol reacts with SOCl2 sulfonyl chloride in presence of the pyridine as a catalyst here, pyridine as a base here, and here to form RCl alkyl chloride and SO2 sulfur dioxide and HCl are the byproducts here, and these are in a gaseous state here. Now this reaction is very important because in this reaction that HCl and the SO2 both byproducts are in the gaseous state. Therefore in this reaction the alkyl chloride is prepared is 100% pure here. Now here on this reaction that the certain MCQs may ask, for example, that from the following reaction the alkyl chloride, from the following reaction that the alkyl chloride is obtained as a pure, find out that reaction. So in this way that the number of reactions are given, and from that reaction this reaction is the correct one reaction. Okay, so in this reaction also we are going to take here that the primary alcohols, secondary alcohols and the tertiary alcohols. In one sentence I would like to tell here that here the primary alcohols when react with the sulfonyl chloride to form the primary alkyl chloride, secondary alcohol reacts with the sulfonyl chloride to form the secondary alkyl chloride, and when tertiary alcohol reacts with the sulfonyl chloride to form that is the tertiary alkyl chlorides here. Okay, so this finishes that the reactions of the monohydrate alcohols. Now come toward that the last point, and it is the uses of the ethyl alcohol. Just I would like to tell here 2 to 3 uses of the ethyl alcohol. As that the ethyl alcohol is a very common, or actually it is a very important one. That's why we are going to discuss here that the uses of the ethyl alcohol. Now this ethyl alcohol is used as a solvent to prepare that the many compounds like acetic acid or the acetaldehyde, etc., etc. Okay, so it is used as a solvent for the manufacturing of the many compounds. This one is going to be the one use. Then ethyl alcohol is used as a solvent in the preparation of the oils, gums, resins, etc., etc. It is used as a solvent in the preparation of the oils, gums, resins, etc. Then ethyl alcohol is used as alcoholic beverage here. It is used in a alcoholic beverage. It is used in a alcoholic beverage. Okay, so you know that the all that the beverages contain that the alcohols here. Okay, so this is the one use here. Actually, when we take that the ethyl alcohol in a small quantity, actually then it does not causes any that the problems. But when the ethyl alcohol is taken in a large quantity, then it causes to our health. Okay, so this should be the one use here. Then next one, ethyl alcohol is used in the thermometer. It is used in the thermometer. Then it is used in the preparation of the drugs, dyes, etc. The next use is that ethyl alcohol is used as a, and it's a, actually it is used in a antiseptic. It is used as an antiseptic. The next one, ethyl alcohol is used in the manufacturing of the soaps, and particularly that the transparent soaps. To make the transparent soap, that ethyl alcohol is used. Okay. Then next use that the ethyl alcohol is used as a substituent of the petrol. Substituent of petrol. 10 to 20% ethyl alcohol. 10 to 20% ethyl alcohol. When it is mixed in the petrol, then it acts as a good that the substituent of that is the petrol here. Okay, so in this way there are 5 to 7 to 8 uses we have seen. So this finishes at the alcohols. Now after this, that the next article from this topic, it is the phenol, and that we will discuss in next year.